Now the one side limit. The one side limit of function. So the definition is, we know that you may have seen the things of left hand limit and right hand limit. The simple thing, x tends to c. It means that x is approaching to a value c on a real line. If this is c and we are in the neighborhood of c, so some delta neighborhood. So to approach, x is trying to approach the value c. So x can approach from the left side and x can approach from the right side to achieve the value of c. Right? So the concepts introduced, these are the right hand limit and the left hand limit. So the right hand limit. So let A is subset of real numbers and let f is function from A to R. So the right hand limit, the definition is, if a real number c is a cluster point of A, cluster point or limit point of set A, then we say that a real number L is a right hand limit, of function f at point C. Is cluster point of set A intersection with C infinity. That means on this part, intersection of A with C infinity. So it is the set when x is element of A but x is greater than C. Right. So this is the case if x is greater than C. So you might have seen this thing, x tends to plus C means x should be greater than C. And therefore that is limit of f when x tends to C plus is equal to L. X tends to C plus, this thing means x is greater than C. And the next other thing, left hand limit. So it means when x is less than C. So the definition is, if C is real number is a cluster point of set A, and now we have to take the intersection of set A with this part, the left side of C, which is minus infinity to C. That means it is equal to the points of set A which are for which x is less than C. Then we say a real number L is a left hand limit of function f at point C. That is, we write limit of function f when x approaches to C minus, that means x is less than C. The limit is L. And we know that for example, fx is modulus of x divided by x. Then limit of let us find left hand limit and right hand limit at x equal to 0. So the left hand limit, limit fx when x approaches to 0 minus the left hand limit. So when x on, so the graph of modulus of x is this. If this is x-axis, this is y-axis, this is origin, and we have to find the limit, left hand limit and right hand limit in the neighborhood of 0. So in the neighborhood of 0, on the left of 0, these are negative values. On the right of 0, these are positive values on x-axis. So if x is negative when x tends to 0 minus, that means x is less than 0. Right? So in this part, x is less than 0, that means x is negative. So for the negative values of x, modulus of x will be minus x. So the limit will be limit of minus x divided by x, it is minus 1, and so limit is minus 1. Similarly, the left hand limit when x tends to 0 plus, that means x is greater than 0. So in the neighborhood of 0, x is greater than 0. In which part? In this part, x is greater than 0. And if x is greater than 0, so by the definition of absolute value, modulus of x will be x. So x gets cancelled. So limit of 1 is 1. So these are the left and right hand limit of the function modulus of x upon x. Then the next theorem. The statement is that let A is subset of real numbers. F from A to R is a function, and let C is a real number which is a cluster point of set A. Cluster point of both sets let me call it as C minus delta to C and C to C plus delta. That means the left hand side of the neighborhood and this is right hand side of the neighborhood. Then limit of function f when x approaches to L if and only if the left hand limit of the function when x approaches to C is same as right hand limit of the function when x approaches to C, and it should be same some real number L. It means what? It means that is limit of fx x tends to C exists if and only if both left hand limit and right hand limit, left hand limit and right hand limit both exist at point C. Right? So therefore we have seen that example limit modulus of x divided by x when x approaches to 0, it does not exist. Why it does not exist? Because we have seen that previously. The example that the limit of modulus x upon x when x approaches to 0 minus is minus 1, and limit of modulus x divided by x when x approaches to 0 plus is plus 1, and they are not same. That's why the limit of the function does not exist. So limit of function exists if and only if both left hand limit and right hand limit exist, and and are equal. They have to be exist and have to be equal also. The infinite limits. So the definition is, there are two definitions: the infinite limit when x tends to infinity and x tends to minus infinity. So the definition is, let a is subset of real numbers f from a to r is a function, and let c is a real number which is a cluster point of a, cluster point of set A. Then the first thing, f tends to infinity when x approaches to c, that is, limit of f of x is infinity when x tends to c if for every real number alpha there exists some delta greater than 0 such that for all x in A with 0 less than mod x minus c less than delta, then the value fx is always greater than that alpha, every alpha that we are taking. That means if I choose alpha to be 1000, so I can have, there exist delta, so that I can have value of function greater than 1000. If I take 1 alpha equal to 1 lakh, so I can have value of function greater than 1 lakh by the same way. And the other definition, fx tends to minus infinity as x approaches to c, that is, limit of function f of x when x approaches to c is minus infinity if for every alpha or beta, real number beta, there exists some delta greater than 0 such that for all elements in set A with which lies in the delta neighborhood of point C, for every beta I should have a value of function less than that beta. So let us see example. So example 1, the limit of 1 upon x square or 1 upon x square okay, 1 upon x square. So if alpha greater than 0 is given, so then let delta, choose delta to be 1 upon square root of alpha. So then if we choose delta equal to this, then if x lies in a delta neighborhood of 0, then what happen? Then x square is less than 1 upon alpha. So as mod x minus 0 is less than delta, that means mod x less than delta. So x square less than delta square, and delta square is 1 upon alpha. So x square less than 1 upon alpha, and it implies that 1 upon x square is greater than alpha. So for every alpha greater than 0, I can have value of function to be greater than alpha. So the limit of x tends to 0, 1 upon x square. So by the definition of infinite limit, it goes to infinity. The second example, if I take limit of the same function with minus sign, so definitely it will go to minus infinity. So the exercise example for homework is that find limit of 1 upon x when x tends to 0. So there are two cases. See the graph of this function, x-axis, y-axis. If we consider a very small delta neighborhood, small to say and this is big to visualize only. So the graph of 1 by x is this in positive first quadrant, and in the third quadrant it is like this. So what happens to the graph? What happens to the function in this small delta neighborhood? I am repeating that this is very small neighborhood. It is only big to visualize. Right? So in this right side limit, the function is increasing. That means x is very small, so function is increasing, value of function is very large. So the limit will be, it will go to, so if 1 by x, if x tends to 0 plus greater than 0 but very small, then 1 by x tends to infinity. It is increasing, and along this positive y-axis y is increasing. So when x is very small but positive, then 1 by x is very large and positive. And if x is negative in the neighborhood of 0, so x is very small but negative, then function is increasing in the along the negative y-axis. So 1 by x tends to minus infinity. So both the left hand limit, right hand limit, they not exist, but the left hand limit converges to minus infinity, the right hand limit goes to plus infinity, so the limit does not exist. Then the next theorem, limit at infinity. Definition is this: limit at infinity. Let A is subset of R, set of real numbers, and let f from A to R be a function. Suppose A to infinity is a subset of A for some real number A. Then we say a real number L is a limit of f as x approaches to infinity. That is, limit of f when x approaches to infinity is L. If for given any epsilon greater than 0, there exists some number k which is greater than a such that for any x greater than k, modulus fx minus L is less than epsilon. So read the definition again. The limit of f is L if for any given epsilon greater than 0 there exists a real number k which is greater than a such that x is also greater than k. That means k is greater than a and x is greater than k. So x is very large, that means x tends to infinity, then mod f minus L is also less than epsilon. So let us see examples. Example. Limit of 1 by x as x tends to 0, x tends to infinity. So by the definition of limit at infinity, if we consider x greater than k greater than a, so as x is greater than k, what we wish to show? The limit is 0, that means 1 by x minus 0 is less than epsilon, right? So if we consider by the limit definition of limit at infinity x greater than k, so then 1 upon x will be less than 1 upon k. Am I right? And as it is greater than 0, so 1 by x is also greater than 0, but as 1 by x is less than epsilon and epsilon is arbitrary, so it implies that the limit is 0. So similarly, the limit of x tends to minus infinity, limit of 1 by x will be also 0. So it is homework to you that show that limit of 1 by x square when x tends to plus infinity is 0. Limit of 1 by x square when x tends to minus infinity is also 0.